to plate solve, because without plate solving, it puts a lot more pressure on the mount to find the object exactly, you see. If you can plate solve, then as long as the mount gets it in approximate location, then you're good to go. Oh, look at that. Plate solve succeeded. Now it's sinking. Oh, look at that. Right in the middle of the target. Right in the middle of the field of view, I mean. You know what this bright star is going to be right here in the middle? That is Capella. Isn't that a beautiful sight? Okay, so in keeping with our time, it's 36 minutes after we were supposed to start, and now we can finally go find things, can't we? So for the 11 of you that are on here, I think one of those is actually myself. So really 10 of you. For the 10 of you that are on here, let's start this again now. Let's point you guys back at Astro Planner. We're going to go back to Astro Planner and um, try sorting the list again. It still likes the position of Clark 105. The California Steve M says, nice. From Gnawbone, Indiana. Um, let's try to slew to Clark 105. I'm going to look outside the window. Yeah, sure enough, our targeting software can also slew. So what I'm doing when I'm looking out the window is I'm actually looking at the scope outside my truck, where somebody tell me the temperature. What's the temperature out there? Uh, the scope is doing the hard work out in the cold. Now let's point you back at Sky Safari just for a second, and let's search for Clark 105. Oh, that's not Clark 105. Evidently, if you put in C, it's going to use a different C. I bet it's using, there is a different thing. I'm going to have to spell out the word Clark. Clark 105. Not found. We will use the NGC name then. NGC 1499. NGC 1499. California Nebula. And we're going to center on that. Oh, look. It already thinks the scope is pointed there. So let's just get an idea of what we think we're going to be able to see. Wow, wouldn't that be great to see that if we indeed could do that? We're going to have a little trouble, aren't we, with our field of view. It's not going to quite be able to see all of it. But let's just see if we can find it. Oh my goodness, look at that. That is a lot of... Let's do a restretch there. Let's go back under the name and let's put the NGC name. It is supposed to be NGC 1499. I'm going to point you guys over it. I'm going to point you guys over at SharpCap now. And then I'm going to go join you there. NGC. Let's put in the target name up here. NGC 1499. And the other thing I want to check, let's look up here in our pre-processing. And let's just look at our dark frame. This is a calibration frame. 10 seconds, gain 200. That's perfect. So it is automatically taking care of putting in our dark calibration frame, which is supposed to take care of a lot of the problems with our... And there's the flats frame. It's supposed to take care of problems with our dust and stuff. We need a little bit more signal, don't we? Let's go down here and reset this display histogram. And let's let that frame come in. Feel like I'm in the map room on the USS Enterprise looking for the Nexus. 55 in Orlando. but that doesn't help you. 28 in Gnawbone, 30 degrees in Taylorsville. Oh, that's not so cold then. All right, now this display stretch, the first thing we want to do is our plate solve and resync because we want to make sure that we're pointing right at, now look how I'm getting some vignetting, they call it. Look how these corners are just the slightest bit dark. Now I knew that I'd get a little bit of vignetting with this new camera that I'm trying tonight, but I thought that with my flats that I would have solved the vignetting problem. So evidently I have not. I'm going to have to do a better job. Um, oh, look at that. Plate solve succeeded. Position found. We're recentering on the target. Yes! All right, now what we're going to do is once this settles down, we're getting a lot of moonlight, aren't we? And clouds. But let's just wait till that settles down. See how we're still getting some star repositioning here. Let me make sure you guys, yeah, you're viewing what I'm viewing. Now, see the stars have settled down. So now we're going to come over and reset this display histogram. And I think what we'll do now is we'll start live stacking. And when we live stack, we want to clear what was in there before. We want to reset this histogram. That's the color. We want to reset that histogram. And now let's wait for it to bring some frames in. While we're waiting, we'll just let it start to accumulate some frames. So what this is doing is it's taking some pictures now, and the exposures are about 20 seconds long, and we're at 200 gain. Now what gain is, it's like turning the volume up on an amplifier so that we can get some extra light into the picture. So we're trying that. We're also using 20 seconds. 20 seconds is a pretty good, that's probably the most we'll have to do, I hope. So it starts stacking frames. You can see we already have 2 frames stacked down here. I don't know if you guys can see my mouse pointer. Are you able to see my mouse pointer? I can't tell if you are. If you cannot see my mouse, look down here in the lower left under the word overview. And underneath that, there's this line called frames stacked. And you can see now there are 3. I think what we'll do is we'll reset this display histogram one more time. We'll reset this live stacking histogram. And we'll reset this color. And we'll try to do the color balance based on the peaks. And then we're going to just try this auto stretch. Oh, look, turn on logarithmic and try auto stretch. And I don't have luck much with that auto stretch. We're going to put our black value just so that our sky gets pretty dark. So we're doing 2 things. We're looking at our arch of our peak, and I'm going just a little bit past the right of the peak. And then we're going to take our whites and try to make them as white as we can. So we're going to move that white up there. Then now we have to play with our mids just based on guessing. With an object like this that's nebulosity, we want to get our mids fairly close here so we capitalize on that. Now I just want to remind you for a second. Let's go. I'm going to point you guys, first of all, while that's accumulating, I'm going to point you guys back at Sky Safari. And we're going to go back over here. So you see what we should be looking at. We should be looking at a nebula that looks like this. Now, while that's accumulating, I'm going to try something else. I don't know if this will work. Let me see if I can add an audio source for, how would I add the computer's audio source? What I want to add is the I want you to be able to hear the computer. And let's create a new, and let's call it computer audio. And let's try to search for it. And we're going to use something like, I don't know. Let's try USB, I guess? No, that would be that's off the webcam. What if we try this? And so we're going to make that live. Oh, yeah, you're hearing the microphone. I hope that'll let you hear. So I'm going to mute my mic for a second. And I'm going to try to play. I'm just going to try to play this. I'm going to go into our object. I'm going to go into our object information here. Oh, after all that, there isn't even any audio. A lot of these objects have a computer narration of the script here. I was going to play that for you, but unfortunately, it didn't. So I'm going to mute the laptop for a minute and go back to my headset. I'm just going to have to tell you this. Although nearly 2.5 degrees across in photographs, the California Nebula has a very low surface brightness, which makes it disappointing and difficult to see visually. It is a faint rectangular patch north of the fourth magnitude star, whatever that is, Persei. Would that be Chi? Tim, can you look back in your Greek alphabet and what would you pronounce that? XI. Would that be Chi? Russ says, why do I hear Frank Sinatra? Several streaks of low surface brightness cross the nebula. An H beta filter is helpful when attempting to view it. In a rich field telescope, we do have a rich field telescope we don't have dark skies. We have 100% moonlit skies, plus the light pollution of Louisville. Instead, this nebula is a great target for astrophotographers. Right, well, we're not astrophotographers. Tim Stapleton says 11. I don't know what that means. The California Nebula lies some 1,000 light years away. 1,000 light years away. So what that means is that the light that we're going to look at in a second started traveling toward us a millennium ago, 1,000 years ago. And it's just little bitty photon packets traveling through empty space with no solar system, no planets, and it's been skipping across empty space toward us. It's in the direction of the outer Orion arm of our galaxy. This entire region of space is filled with galactic gas, from which many massive and luminous stars have formed. The glowing portion of the nebula is about 100 light years in extent. What does that mean, extent? NGC 1499 is probably illuminated by whatever that Greek letter is. I've forgotten all these. I'm going to have to go back and... Is that Eta? Eta? Eta Persei, maybe? A hot blue-white... Now, I'm guessing that's this. A hot blue-white main sequence star is spectral type O7e. This star belongs to Persei's OB2. That's not to be confused with OB1 Kenobi. This is OB2 association, a group of young stars which probably arose from this interstellar cloud. The brightest star is Persei's OB2. What is that Greek letter? Theta Persei is a beta B1 LB white supergiant, which shines at a magnitude of 2.83, some 0.6 degrees south. Maybe that's this of the California Nebula. So what we're going to try to do is make our view look like this. And look how we've got some extensions here that we're going to have to try to find. And boy, we'll be happy with looking at any of this, won't we? Okay, so we're going to go back and point you guys at SharpCap. And then I'm going to come back and join you. Oh wow, this is nice. 23 frames we've got stacked. Let's take our dark uh, black level and let's move it a little bit closer. Boy, that moonlight is hurting us, but we're going to try to get right at the top. Tell you what else let's do. Let's do our color. Oh my goodness, what a mess that is. And then oh, we're actually not bad on our color deal here. I wonder if we should reset this histogram altogether. Will that get us in a lot of trouble? Yes, it did. Let's go back and bring our black. Boy, look at that. Let's do our, let's bring our blacks back up to right there or so. Right there. Let's bring our mids now back. There we go. Look at that. Some of that is, I fear some of that is moon glow. If you go outside or go to a window and look at the moon, it is full tonight. So I think some of that is moon glow. But you can at least see, and I'll tell you what else we'll do. We'll get this so that the moon glow is mostly gone. I'm going to hold my shift key down, and that'll let me play with this mid-level a little more. Look at all that moon glow. Oh my goodness, look at that moon glow. Let's try right about there for a minute. Tell you what else we can do. We can dial down this green a little bit, and that'll help us. Yeah. Now what we'll do is we'll take this back, and just for a second, let's just admire that. And I wonder, see these extensions here? What this tells us is we've got the right side of the frame with our viewfinder. Remember when we were looking over, I'm going to just take you, if you don't mind, I'm going to put you back over in Sky Safari just for a minute. This just tells me that I don't have my field aligned correctly. So here's what I'm going to do. I'm going to go here under Observe and look at Scope Display. Oh, look, field rotation angle. It's set on 83 degrees. So we need to change that. I'm going to go back right about, I'm going to put this back on 0, see? Because we didn't need that field rotation. Yeah, because here's what I'm telling you. Now remember what that looks like. Kind of memorize what that looks like. Can you see how this looks like a big toe? Oh, Tim looked up the Greek for us. Thanks, Tim. Psi. See how that looks like a big toe? And then look at how these look like 3 smaller. Let me get rid of this. How do I make this stop showing you the scope thing? Yeah. See how that looks like a big toe and several small toes? Oh, by the way, this star is called Menkib. Menkib. That's interesting. And look now, we can capture that whole nebula. Now, let's go back to SharpCap. I'm going to put you guys back in SharpCap, and then I'm going to come and join you. Look at that. This is a live stacked image. Just for a second, let's see how many we have. 35 frames. So we've been stacking for 11 minutes and 40 seconds. You know what we can do is we can bring ourselves a little bit more black, I think. And that'll help us pick up a little more nebula, maybe. I'm going to hold my shift key down as I turn this, because we don't want to get back in all that, we don't want to get back all that moon glow, do we? Because that moon glow is a bummer. We're just starting to get some of that moon glow. Because we don't want that. Now the other thing let's do, let's boost our vibrance a little bit. I don't think it'll help us to play with this white level any. I think that white level is best left right where it is. Oh, I don't know. That might be helping make this a little more vibrant. Let's bring that white down. You know why? Because look, we don't see this curve. We don't have much information there. Look at that. There was a bit of information right there, but that information is not helping us. Let's bring this white over to about there. No. This is almost like art, isn't it? It's really not very scientific what we're doing now. What we're trying to do is find the right color balance. Let's do this. Let's just start from scratch here. And let's try resetting on the stars. Boy, look at that moon glow. Well, the stars didn't help us much today. Unless when we reset this. See our peaks? They're not aligned, are they? So let's go back to our aligning with our peaks. Let's put this black level right there, and let's put it right on the peak. Let's leave, because look at this little bit of information here, whatever that is. That might be that one white star. Now let's bring this mid-level back and get our nebula back. And then remember how I told you to memorize the way it would look with the big toe? Because what we're seeing here, right over here to the right of the image, we're seeing that big toe. I'm going to take the green down just a hair to get rid of some of that moon glow. Steve, thanks for stopping by. Look at that image, my goodness. That is so fun to pick that out of a moonlit sky with Louisville light pollution. Now, I'm going to tell you, I'm going to be honest. We are using one filter tonight, and that one filter is a Celestron light pollution filter to try to cut out as much of the light dome of Louisville as we can. And it is doing us a grand job. Wow. I just really love that. I hope you guys do too. Remember what you're looking at. Kind of mark this down in your mind. There, Penny says, beautiful. Bless you, Penny, for that encouragement. Remember what you're looking at. NGC 1499. You can go to Wikipedia and look this up. Look up NGC 1499 and you'll see this California Nebula. I suppose they call it California Nebula because they think it resembles the state. But I think it looked more like a footprint to me. Look how there's a little bit of dark. You know what I'm going to do is I'm going to zoom in just a little bit. Let's zoom in about 40%. That's way too much. Zoom in 25%. Look at this dark spot here. Now my theory is that that dark spot might be a piece of dark nebula because the odds of all that dust suddenly just being vacuumed out of that spot, those odds are not great. It is much more likely that that is a piece of dark nebula. Let me just zoom in a little more. Now see with this new camera, look how we can zoom in with this new camera. I am not used to being able to do this with my old camera. If we would have tried to zoom in like this, everything would have been so pixelated. It would be ridiculous how pixelated it would be. But look how with this camera, we are still zooming and it is still acceptable image. And look, I think this is dark, like maybe a dust lane, some kind of dust lane here in front of it. Tell you what, that is a beautiful scene. We have it really well framed. We're seeing those toes. We're out here. Let's go back to the auto view. That's actually not bad framing as well. If we go to 16%, that's a little bit better. Now, I'll tell you what we're going to do. We're going to get our live stack quadrant back because now we're going to save an image of this. It's not letting us save a PNG. That's interesting. I wondered about that because look, we're up here under image controls. No, where was it? I noticed that it was not giving us a PNG, wasn't giving us the option of saving with a PNG. So that's okay. It just means we'll have to, oh look, here we go, capture profiles, capture format. Oh, output format, PNG. We should be able to do that. Oh, I got that. Here we go. Here we go. This is what we want. I was going to save the raw frames. Let's save exactly a scene. So now it's saving that. It's waiting for the next frame. Now it's saving that wide frame, even though we panned off of that. It's saving the whole frame. So now I'm going to just look at that frame here in my laptop. This is off camera that you guys are not going to be able to see this. I'm going to just make sure that that's saved okay. January 29th, NGC processed. I'm going to open that up. And it's open. Oh my goodness. Yeah, that saved it exactly like we are viewing it here in the frame. It saved it exactly the same as what we see it. So that's our first object. We spent 19 minutes on that, but that's because it's a very difficult. Hey, Larry Fraley's out there. Larry, it is so nice to have you here. I don't know when you joined, but we're looking at the California Nebula, and this is NGC 1499. We are so honored that you are here with us. We just read over here in our planetarium program, which is called Sky Safari. We were just reading over in Sky Safari how difficult this object is. It is just a very difficult and disappointing object most of the time. So we picked a tough challenge, but by God's grace, our frame ended up looking pretty much like uh, this frame thought we should look amazingly in our. This is just Sky Safari, just a planetarium program. So we're really happy with that. We'll save it one more time just because we did pick up a couple of frames while I was talking there, and then we'll go into our next object. Thank you all so much. Larry's been with us 20 minutes or so he's already picked up that. I see we've got still around 10 people with us, and I appreciate you guys being here. For me, that's about the right size crowd. I'm not ready for big crowds yet, as you can see. I am still learning this. I just want to remind you, I've only been doing this for, this is, I think, my sixth or seventh time out with this telescope. We're using a RASA. You know what I'm going to do, just for fun? I'm going to go back over here to our. I'm going to put you on what should be the scope cam, and you can see how dark it is. And I am going to go outside, and I am going to move the webcam because it is not, apparently, it's not pointed at the scope. I'm going to move the webcam, and then I'm going to try this again. Okay, let's try something like that because it just makes such a difference when you can see. You can see that telescope. I think it makes a difference. Now what I have to do is have to literally right now aim my flashlight out the window. No, we're still not getting that. So I think what I'm going to do is ditch that, and then I'm going to re-add it. So I'm going to say, what would that be called? A video capture device. And we're going to say webcam 920, just so I can tell what I'm looking at here. And then it's gonna, there we go. And then activate that. Wow, and then make that bigger. And now, is that what you guys are looking at? Yeah. So what this is it is a Celestron RASA. And that RASA is an acronym, stands for Rowe Ackerman Schmidt Astrograph. And the funny thing about this telescope, I don't know if you can tell, there is no viewfinder. It's just basically a tube, and a big one, an 8-inch tube. But what that does, because it doesn't waste time and waste design on a viewfinder, it folds the light just one time. I don't know if you can see down there at um, the bottom of the scope. That's that's the bottom. There's just one mirror. Then it bounces back up, and then up there at the top, this black section is it's actually a dew finder. Dew finder. Listen to me, a dew shield. Um, Inside that dew shield that I can't show you right now is the actual camera. And tonight, for the first time, we're using a ZWO's ASI 2600, uh, a 2600 MC Pro camera. And I am so happy with our camera tonight. This is a new experience for me to have this. This is an APS-C camera. What it's doing is it's literally bleeding every last photon that it can pull from this telescope. This is a very fast uh, optical tube assembly. If you're familiar with photography, this is not f10. You know how you list lenses with focal length. Uh, this is not f10 like my last telescope. This is not f5.6 or something. This is an f2 telescope. And it is very fast, extremely fast. On top of it, by the way, this little deal here is a Telrad viewfinder, and that's the mount. This mount is as expensive as the telescope, by the way, but the mount is what allows us to be able to find these objects. The mount is a Skywatcher, and it is an EQ6R Pro mount. And then we have all this cabling that drops down from the scope, and the cabling comes inside the vehicle where I'm sitting, and that enables me to be in here, and the temperature right inside of here right now is 72, whatever kind of night it is. So it's kind of a fun, it's a fun telescope. It's the deal tonight that we're celebrating is this camera. It's definitely a new experience for me to have this nice of a camera on the end of that fast scope. Let's go back to our targeting software. I'm going to have to take my coat back off. My goodness, it is hot in here. The one thing I want to do before I leave here, I want to get in the habit of saying is I want to do an observation for this. So make an observation, and we're just going to quickly type in here, wow, moonlit night, light pollution from the Ville, but still managed to pull in California nebula. So what this does is it makes an observation record in the observation database, and notice how it's recording all this stuff about what we're experiencing here. And what this enables me to do is to be able to go back and see what we've looked at. And what I'll also do is I'll go grab that little PNG photo that we took. And so we're going to look at January 29th here in this. And there's the photo we took. And so it basically puts that photo and links it with the object, so that from now on, I'll have a photo of the California nebula. Oh, and you know what else I need to say along with this is I need to say this was the first image with the 2600. That'll be a forever memory for me to be able to have the California nebula be the first image with the 2600 camera. Larry's asking, what size image does the camera take? That is a great question. I can tell you that exactly. Um, I know right where to look for that, but it's brand new for me, so I don't have it memorized yet. But I tell you what, we can go over here to SharpCap, and in SharpCap, we can look up here 6,248 by 4,176 pixels. It's about a 21 or 22 megapixel image, and it's taking it in RAW 16, so that's 16-bit. And what is amazing about this camera is the sensitivity that it has. It is probably the most sensitive camera I will ever be able to afford in my life. I'm going to take one last picture here before we leave this and stop the live stacking. Now, let's just look at that one more time. My goodness, you know what else I'm going to do? There is a there is a command here to let me see this full frame, and I don't even know where it is. I've just not done it before. But anyway, I just had to stop and admire that. That was a beautiful image. Let's go back to Astro Planner and let's head to our. Larry says, "Wow, that will make a great metal print." Well, I hope you're right, Larry. I pray. Now, what we're going to do is sort the list again. So every time we sort here, we're sorting the list of objects that we've never observed. By the way, look how it's put a 1 there under observation. So now it knows that I've done that. Uh, we're going to sort by is it visible and take the highest objects. And let's go to M34 now. And I'll tell you what we'll do. Before we do that, I'm going to have you go back to the scope cam, so to speak. And now when we slew to M34, hopefully you guys will be able to watch that and see this robotic mount obey, try to find M34, spiral cluster. So you're watching it slew there. This is an equatorial mount, a German equatorial mount. So you can see these weights balance out the weight of the scope, and it turns on 2 axes. The first thing it does is it gets it aligned with how high the object is in the sky. And then the other axis is parallel with the North Pole, so it can just spin on one motor. Oh my goodness, Penny's saying, love your new camera. I got to tell you guys, this is extremely important because she knows how much we saved and invested in that camera. So she knows what we spent for it. So I'm really loving that she likes it. That's important for us because she knows what it cost us. Anyway, now that the scope is tracking this object, it doesn't have to use 2 motors anymore to track. It can just worry about 1 motor at a time. And we love that because we don't want to have to worry about 2 motors because that's much harder to synchronize. Now we're going to go back to our planetarium program, Sky Safari M34. Tim says, is that a highway in Missouri? Oh, there's ethics team. Boy, I got to watch what I say now. I'm sitting up in my chair. You should have seen me. I immediately straightened up because whoever the ethics team is here with us. Or is that EIHCS TTAM? Eeks team. Anyway, somebody's saying beautiful. That's very kind of you. Praise God that we found one object. Okay, I'm going to go join you now in the planetarium program. And we're going to search here for M34. And you can see this is a Messier object, and it's this cluster. So first of all, let's center our planetarium program on that, and you can see it already has its field of its perception of where the telescope is pointing, because this planetarium program is tracking 2 things. It's tracking where I point it, so I can go search for whatever I want. I can search for Polaris again, and I can make the planetarium program point at Polaris. See, But that doesn't change, even though right now we're centered on Polaris, it doesn't change where the planetarium thinks the telescope is. Because the planetarium is telescope aware. Sky Safari is telescope aware. So we're going to go back now to where it thinks the telescope is. And it thinks the telescope is on M34. And let's hope it's right. I got to tell you, while we do this, can I just tell you while we're looking here, Sky Safari is not available in Windows. It is a Mac program through and through. So see, Larry is going to like that because Larry is everything Apple. He's just in the Apple universe. So he can use Sky Safari native and it works for him. Me, I can't. So here's what we're doing in Sky Safari. I don't know if you can see. We are actually using the Android version of Sky Safari, which is a thing. You can get it on Android, but you can't get it on Windows for whatever reason. And then what we're doing is we're using an emulator called BlueStacks. So we've installed an emulator inside of Windows. Then we bought the Android version of Sky Safari and found a way, believe it or not, we found a way that it wirelessly emulates because Sky Safari, Larry says, I'm going to go get it now. You'll love it, Larry. There are 2 or 3 versions, Larry. The cheapest version is little or nothing. The one that has all these zillions and zillions of stars, you can see, man, we have lots and lots of stars in the view here, and they just keep on going. The one that has all these zillions, zillions, zillions of stars is not that much. I think it's like $15. I mean, that's a lot, isn't it, for an app? I bet we could take a poll here. Probably nobody in the entire audience has ever spent $15 for an iPhone or an iPad app. But Sky Safari is probably worth it if you want all these low magnitude stars. If you're just going to look at the visible stars that you can look up in the sky with your naked eye, then the one that costs whatever it is, $3 or $5 is just fine. So anyway, we connected this through an emulator, and we used a little bridging program that thinks it's wirelessly talking to the telescope, but it's not. It is actually talking to the actual planetarium program that we have here to the actual server that we have here on our laptop, and that server is called Green Swamp Software. You know, I wonder if I have a thing here so I can show you Green Swamp Server. Yeah, I do. Now, can you hear me still if I go over there? This is actually the server that acts as the pointing software. And everything that we're using here works through this software called Green Swamp Server. And you can see it's got a little graphic of the telescope, and it's got it pointing up at M34 in its mind. You can see the tracking is on. All these adjustments and stuff I can mess with. And Sky Safari thinks that it's wirelessly talking to the telescope, but it isn't. We have a trickery bridge installed in Windows to be able to trick Sky Safari. And so I just had to tell you that little story because it's kind of a fun thing. Now let's do one more thing back in Sky Safari. I'm going to point you guys back to Sky Safari, and then I'm going to go back and join you. Let's get an idea of what this should look like before we go over in our camera. Got it. So it's going to look like this cluster here. And this is the size of our viewfinder. So now let's go back to SharpCap. I'm going to point you guys back at SharpCap. Then I'm going to go join you there in SharpCap. And the first thing we need to do is name our objects. This is M34. Then the next thing we do is reset. I'm going to get rid of that and go down here and reset our display histogram. We should have been accumulating frames all that time. Boy, that just is a sign that I'm new. See, I should have been having us accumulate frames. Now we're going to do our plate solving. And remember what we do when we plate solve? It tries to find where we are pointing in the sky. And if it's successful, it says, you wanted to go to M34, but you're just not quite pointing at M34. Let me help you a little bit. And then what it does is it synchronizes the actual pointing of the telescope with the actual mount, and then it makes an adjustment so we're that much closer for the next object also, by the way. It succeeded. So what it's doing now is it's recentering, and uh, if we could see our objects right now, look, Tim's saying green swamp, blue shields, emerald hills. I'm glad you're color coordinated. That's the last thing I am, color coordinated. Uh, okay, it says it's synced. So now we're going to reset this display histogram one more time. I suppose I should wait for it to accumulate one frame, and then we're going to recenter it one more time. And what that does is it lets the software know this is the object we want to look at. And now the next thing, let's see, we've named us. I guess we're ready to start live stacking. So now we're going to clear the live stack. And we're going to look how we got to bring this up a little bit to see. We're going to reset the live stack. And let's just do an auto stretch quickly. But let's also reset the color balance. Now, when it first comes in, it's kind of haywire, but I can already see, and I don't know if you can see it also up here. You probably can't see my mouse point, can you? That's a bummer. In the picture, in this, oh, look, there you're looking at a mouse, but it's not looking at the same place. That's odd. In the upper left center, that's what I'm going to say. In the upper left center of this picture, you can already see that cluster start to form. We're going to do another reset of the color balance and try to start. That's much more like it. Now we're going to move this peak, this black level just a little bit to the right of that peak. I'm going to hold the shift key down while I move that, and that doesn't move it as profoundly. Now that greenish tint there that you're seeing is moon glow, and that's unfortunately tonight. But you know what? I got to tell you, this is the world's worst night. In fact, when I was first trying out targeting software, I got to tell you, the first targeting software I tried, which was the most expensive targeting software we could have used, it wouldn't have even let us look at this object tonight, because what it did is on 100% moon nights, it just basically said, it's not worth it. You might as well not even go. And the reason why is because it didn't like this moon glow. But with the magic of EAA, which is electronically assisted astronomy, what we're doing now is we're starting to filter out that moon glow by working with our software here. And I'm going to move this black level a little bit to the left to try to court a little more. Now, see how they've got that white down here? I think that's because it thinks that that's the last white peak maybe. So I'm going to put that just to the right of that white peak. And then I'm also going to take this mid-level and I'm just going to try to see a few more of those stars without turning this totally red. And for that, I'm just going to manually grab this red and bring it back down. Wow, look at that. Now we're talking. This is a little better. These peaks are starting to align. So we have enough of our stacks. So what is it doing when it live stacks? It's actually taking multiple pictures of the night sky. And as you can see up here, every picture is 20 seconds. And we're still at 200 gain. You know what I would like to do? I'd like to get this down to 100 gain. Wow. Well, I won't mess with that right now, but before this night is over, let's get that down to 100 gain. The reason I say that is because that maximizes our camera sensitivity. If we can get that down to 100. Anyway, what it does is it takes a picture every 20 seconds. I mean, these are time exposures, 20 seconds long. And what it does is it takes the first one, and then it lays the second one on top of it, and then it lays the next one on top of it, and it keeps stacking. And what it does is it tries to figure out, what is this guy trying to see? And it eventually figures out what we're trying to see. Look at all that blue. It didn't like that, did it? Do I dare color balance it again? Let's try it. Oh my goodness, look at that. What a mess. There we go. We're back. Let's bring this a little closer. Now we could bring this white in and see if that would brighten up our star some. Yeah, it does. But now we're going to have to try to get rid of this. Look at that. Let's get rid of that green moon glow. Yeah, I just don't think we can do the white level that low. Let's put it back here where the... And now let's go back and try to... I'll tell you what else we can do. With this camera, thanks for sharing the skies with us. I've got to run. Have a good night. Russ, thanks for stopping by from down in Orlando. You've got the good weather for observing. Tell you what else we can do with this camera. Since we've got this camera, let's put this on about a 40. Oh my goodness, look at that close-up. That's way too close. How about 20%? We see how we're starting to zero in on that cluster. Look at that cluster. Now, in a way, we weren't bad when we were at 20%. Look at how it's looking at that cluster. And now here's why I say that. Let me point you back for just a second at our planetarium program, and I'll go join you there. Remember how when we were at the selection and we were looking at object, look at what it showed us. This is pretty much the same thing we're seeing when we zero in on that cluster. Now you can see what it says. Oh, look, we got an audio tour. So I can try this. So I'm going to put you guys back in SharpCap. See, how do I do that? I'm going to put you guys back here on SharpCap because I got to see if I can make this, give you this audio tour deal. So you're looking at SharpCap again, and you know what else I'm going to do is get rid of this stacking software down here and let you look at the whole thing. Boy, I wish I could remember how to make it the full screen. There it is, F11. Look at that. Now that's reconfiguring so you can see more of the object. Wonder if I can get rid of this somehow. Yeah. Look at that. Now we can put you right there on the object. There's a little bit of moon glow still there, isn't there? You guys forgive me if I go down and just try to get rid of that moon glow a little bit. A little bit of, here we go. That's better. I think that's it. Okay. Okay. Now, while you're looking at that, I'm going to go over here and go to the planetarium program. Rats, I think I would have to add in the planetarium program, I would have to, oh, there it is, computer audio. It's there. And I just have to, I'm going to mute my headset. I'm going to put you guys back on Sharp. Rats, I wonder if this is going to work. Let me try adding here in SharpCap the audio input of that computer audio. There we go. Now. Okay, now I think you can still hear me over the computer audio, but what I'm hoping is when I go and play this, let's try this. Here we go.
M34 is a galactic cluster nestled on the Perseus and Andromeda border. It is a sparse but bright cluster of a handful of stars. Low powers work best on this object, and M34 is a favorite of owners of large binoculars. It is not really blue star perched immediately nearby, another wonderful sight.
Oh, I was just getting it figured out. Let me just play that just another second. And I wonder if one of you wouldn't mind saying, can you hear it?
M34 is a galactic cluster nestled on the Perseus and Andromeda border. It is a sparse but bright cluster of a handful of stars. Low powers work best on this object, and M34 is a favorite of owners of large binoculars. It does not really improve with an increase of power or scope size. However, for those wishing to use higher powers, M34 has a central double star called H1123. It may be split in a 76 millimeter telescope. M34 is
Okay,
near the bright star
let's
Gamma
stop that.
Andromeda just to the east. This double has a wonderful gold.
Okay, you got the idea, huh? So that's another thing that I'm learning to do right now. Thank you guys for putting up with that. Okay, so this is M34. This is a different kind of object. I'm sure you're picking up on that because of the narration we just heard. The first thing we looked at was a nebula, and that's like a bunch of clouds and dust. It's usually illuminated by maybe a star that's pumping energy into it, and it lights up that dust. But what you're looking at right now is just a cluster of stars. And one way to look at this is probably at one time there was dust in a cluster like this. But through time, thousands of years, whatever you want to call it, just through the breath of God, all that dust blew out. Maybe it was the solar wind from these stars. It eventually blew out all that dust, and now what do you have? You have a group of stars that are traveling through space together. And what I always wonder is, does one of these stars have a planet that we could land on? And if it did, if we landed with our spaceship there and we looked up in the sky, what would this cluster look like to us in the night sky? Would these stars be so bright because it's in the middle of a cluster like that? It would be just like being in the Milky Way, except these stars would be blinding at night and they would all look like giant Venus or Mars level, illumination? Or would it be so bright that it's always just like the moon lit and we always have a kind of daylight going on? And those are the questions that haunt my soul at night. When I come to bed at night, I pull the covers over my head and I get my little iPhone and I look up these different objects. And I've gone through every Messier object and I'm starting in other objects now, just like this M34 that you're looking at right now. And I look them up on my phone one at a time. And I read this narration and I try to figure out what would that look like. So there you have it. We're going to now see if we can put our screen back in order. I'm going to hit F11, and sure enough, it recovered us from our full screen. I'm going to go back to this live stack deal down here and put it back and put our camera controls back. I'm going to save this. So we'll have a record of this that I can then not only put with our observing program, but also just a snapshot in time of what we saw together. And now we're going to stop the live stack and we're going to send you guys over to Astroplanner. I'm going to join you in Astroplanner and we're going to say, make an observation. And then we're going to say, in spite of the moon glow, we managed a beautiful open cluster. And then we're also going to go to attachments. We're going to go grab that. Maybe someone there is sharing a photo of the Milky Way and asking, I wonder what it would be like to be there. That's a great idea. Put things in perspective for us, Tim. We're going to go to this place where we just recorded that picture, M34, and we're going to grab that picture and put it in here. And it's hard for you to see probably, but there's that little cluster. And we are done with our observation. You can see it. It recorded that observation for us. And then what I do at the end of a night's observation, I clean out the targeting list, and I the software keeps track of the things that I've observed, and they are here under let's see, under observation, show observation database. I don't know if you're seeing that or not. You might not see that because it is a separate window, but in my screen now, I'm seeing the object database, and it shows me all the things that I've observed in that window. But I bet that opens up as a separate window. So the way I have this live streaming working, you're probably not seeing that separate window. But trust me, we now can filter those out. Okay, I'm going to go to this sort, and we're going to try to do another couple of objects now. We're going to hurry up our pace a little, and in the last 23 minutes, we're going to try to do at least 2 more objects. So I just did another sort, and it's finding another thing that I've never visited before, NGC 869. That's another open cluster. Oh my goodness. Let's see if we can pull this comet out. It is a Temple Swift comet. There is no chance that we're going to see this, is there? Because it's moonlit tonight, and that expensive targeting software wouldn't have even let me. So I had to get this targeting software, which I actually like better. And I'm friends now with the guy who programmed this. I actually like it better because it gives me the decision. I'm going to say slew to this baby. Oh, but first, I'm going to put you guys in the I'm gonna put you guys on the scope cam, so you can watch it slew. I dropped my flashlight. There's the scope. I'm gonna say slew to the object. So there it goes. Just like a little robot, isn't it? And it's not just a robot. I mean, it's got to be so precise that it gets us within. I mean, our view to the sky is such a tiny, tiny, tiny sliver, and it's got to find that exactly. Isn't it? Just every time it just amazes me that this stuff can even possibly work. What precision we're having to work on. Um, so let's see. We are looking at a comet now, and let's look at exactly what comet this is. 11P Temple Swift. Boy, is that going to be 11P Temple TEMPEL? Is that even going to be in our what are you guys looking at? Are you guys looking at yeah, you're looking at the Sky Safari. Let me join you there. I don't even know if it'll find this. Temple. Oh, look at that. That's it. Temple Swift. 11P Temple Swift linear. Let's center it. Now I'm going to look and see where the moon is. Let's back off. I've lost the moon. Somebody help me find the moon. Oh, no, I still can't find the moon in our planetarium software. It's there somewhere. Anyway, let's try it. I don't see the moon, within 10 degrees. Now look at how we're a little bit off. So let's hope our plate solving can do better, because it is not going to be in our field of view. Now what we could do is we could find a star, but let's just try it first. Let's just go over here to SharpCap, and let's put the name here. This is Comet Temple Swift, and it was called something like 11P. Let's put that name in here. 11P, and we don't need the word comet. Let's just make it 11P Temple Swift. Thanks all. Good viewing. That's very kind of you to encourage. Oh, Larry says, gotta run. You're very kind, Larry. We'll see you next time and hopefully send you a link to a short video if we get this comment. Appreciate you stopping by. I know it's just 6 p.m. out there in Phoenix, so you're probably going to go eat supper. 11P Temple Swift. Am I spelling that correctly? Temple, yeah, Temple Swift. And let's write the word linear here. Linear. Because that seemed to make a difference. Now, the revolution. We're going to reset this display histogram. Let it recover with one frame. Reset this. Yeah. And then we're going to try to plate solve for a comet. Is that even possible? Can you plate solve for a comet? Is it going to be able to look at it? It's trying to find. You know, a comet is in a particular equatorial address. So I guess it's not really solving for the comet, is it? It's solving for the precise deck and out and the altazimuth. You know, it's solving for the declination, the right ascension, I guess I should say, the exact right ascension address and the declination address. Oh, it's succeeded. So it has supposedly found the place where the comet is supposed to be, and it is putting us in that. And it says it's recentering on the target. Now you can see see how the stars are hopping around. Oh, you can't see that yet because I still have you pointing at the planetarium software. Let's point you back at SharpCap. These stars are hopping around, see, because we're on 20-second images, and now we're good. So let's reset the display histogram. Then let's start our live stacking. Let's clear the last live stack, and let's put this on auto, and let's bring this up a little so we can see, because we have to reset the color balance and reset this histogram and just do an initial stretch. Let's let it get two or three frames. While it's doing that, I just want us to go, okay, so it's live stacking now. I just want us to go back over to Sky Safari for a second and see if we can see any information about this comet. Very little. 10th magnitude, orbits the sun at 5.9 years, way far out, 3 times as far as the Earth. So not a lot there that we can see. Not a lot we can learn about it. I wonder if we're going to be able to see this. Let's go and point you back at SharpCap again. And now let me come and join you. And let's do another. Can we see Dancer and Prancer also? Okay, so our colors are starting to align. Let's go just to the right of that peak. Let's put the white level up here for a second. And now let's move this mid-level down, and let's start looking for some picture of some kind of. Now look at these. I don't like these other peaks here. This is what you would call a double stretch. I feel like we should reset this again. Let's let that frame go by and then reset this again and stretch that. Okay, this is better. Now let's reset this again and then stretch that. And then let's reset this color again and see if we get better color align. This is what we want. Now let's bring this black level over to here, just to the right of that peak. Just barely to the right though, because we don't want to miss out on too much of the nebulosity of this comet, or whatever you call that dust, comet dust. Let's move our white level. Look at how we're not seeing very much white. Let's put it right there. Let's move this red down manually, and oh, look at how that messed up our, that's okay. Let's leave that. Let's move this over here a little bit. Right about there, maybe. And let's move this. Look at all that green. That must be our moon glow. I wonder if we're close to the moon. Let's just manually align these for a second, because the automatic is not working for us. Boy, I'm not seeing a comet there yet. Are you all? We have 10 frames stacked, so we should be able to see. I wonder if we're going to have to go a little bit deeper with our time or our gain. Look at how this blue is up here. Let's bring that blue down a little bit. Let's try this again. Put that right there. Let's start moving this in. Let's bring down our red. You know what? I wonder if we color balance this one. This on the right, it color balances on stars. Look at that. Let's reset our color and color balance just on stars, and then reset this and align that. Let's grab this. I bet that's moon glow. Anybody see a comet yet? This is a difficult find on a moonlit night, especially with the moon being 100%. But wouldn't it be fun to see a comet? Tell you what, I'm going to go outside and look and see where the moon is in relation to our view. Yeah, it is just blinding. The moon is blinding. Unfortunately, we have a lot of so back for just a little bit longer, but boy, that moon it is a full moon. It is like if there were werewolves out here at Emerald Hills tonight, they'd be going, oh, 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 oh. Fortunately, we have cleansed all the werewolves. I don't really like to move my laptop around much because I'm afraid we'll lose synchronization with everything. Okay, let's get back here and see what we can do to bring some rhyme and reason to this. There's not a lot of white, so let's pull this white down here, kind of at the end of that, and then let's move this mid-level. Let's move this black so it's just to the right of that red peak. And then let's move this. Boy, you can tell we're getting some crazy information. Look at that signal. You know what I think we'll do is, let's do this. Let's make this 30 seconds. And let's drop our gain down to 100. And the reason I say that is because this camera has a very special setting at a gain of 100. It is super, super sensitive. And we haven't been able to use it yet. Wayne says, probably better try that on a darker night. Enjoyed watching. Yeah, you're right, Wayne. Thanks a lot for stopping by. Wayne, it's good to see you again. We have just 10 minutes left. Boy, I would have liked to have pulled this in. Tell you what else let's do. Let's get this at a point that we're not seeing all that red. It's kind of like with Visine. We're going to try to get the red out. Look at these peaks here. This is just weird. Boy, I'm going to try this one more time. Nope, it didn't straighten that out, did it? Nope. Now look at that. That's actually not bad, is it? So that auto color was doing okay. There's just a slight bit of red, which is okay. Let's put up with that for a second. Now here's what let's do. By the way, let's increase our blue. Oh my goodness, look at that. I needed to trust the auto, didn't I? I would like to find this comet, so let's get rid of this and let's zoom in to about, I don't know, 25%. And let's just do a scan. Since this comet is very small now, help me look as we travel here. In fact, let's get rid of this. And so we're over against the left margin of our scene, and we're at the top. And we're 25% zoomed in. Let's just do a quick pan here. Try to see anything that might have a tail. You know what else? Since we're live stacking, if this comet is moving fast enough, it might also look like something that's starting to smear if it has moved enough. Wonder what that is. See how that's a little bit more like a disk than a pinpoint? Let's zoom in on that some more. Let's go at 40%. Let's see if we can find it again. You know, I just wonder if that's it. Because look how see how these stars, we can zoom in on these stars. Let's try it. Let me show you what I mean. Look how we zoom in on the stars, and we're zooming in on these stars 100%, and they're still just dots. But let's look at that object. That is it. I am pretty sure that is it. It doesn't have a tail, but it is more of a disk, isn't it? So now with that in our frame, let's bring our live stack back up. And just for a second, let's work under the theory that we think that is the comet. So if that were the comet, let's put our black there, and let's put our mid-level here. That is fascinating. See that little spike across it? I think what we're looking at here is a comet with two tails. Now here's what I'm going to do. I'm going to go over to the web real quick. I'm going to say comet Uh, Temple Swift Linear. And let's look at the Wikipedia entry for it. Wiki. Amy Cunningham. This is amazing. Viewing on the big screen TV. Amy, you are so nice. And especially because Jeff told me you were interested in astronomy stuff. Um, it was discovered in 2000. Oh, it was originally discovered in 1869, but it wasn't observed in until later, 1880. They found it was the same comet. Then it was lost and unobservable, rediscovered 2001. I was going to look and see if we can find a picture of it. Let me go to just Google and go to images and look for comet Temple Swift Linear. And I don't know if it matters if I put in the 11P. Um, okay, so let me see if I can find a picture of it. Boy, very little. Um, yeah, very little going on. Look at this. This is, you can't see this, can you? But this is a drawing of what it was theorized that the tail would look like. Hmm. And they do not have in this picture. They do not have a long tail on it for this date. Huh. January. Look, we are just 7 days away from when it'll become invisible. So we're catching at the very end. But I tell you what, uh, we are going to assume that that's it, that the tail is gone, and that those spikes that are going out the side, which are highly irregular, we're going to assume that that's it. And I can move this. You guys are still looking at that, aren't you, in OBS? Yeah. I can move this a little bit closer to there. Yeah, we're going to assume that's it, just for the sake of. Okay, I'm going to save this. And then I'll also follow up with this with some astronomer friends of mine on a forum online called Cloudy Nights. And they'll tell me if we were dreaming. The other thing I'll do just before we go is go back out to auto and look one more time at our big picture. And then I'll also zoom in at something like 75%. And we'll just be comet hunters here for a second. There's actually another object that has that. It has that sort of aura, I guess you'd call it, the aura. But just trying to get some rotation out at the outside of this frame. That's just because we've been stacking for so long. and we're viewing it up close, so close, and our camera field is so big. So those guys on cloudy nights warned me. You get a big field, a big rich field camera like that, and out at the edge sometimes you're going to get a little bit of rotation going on because you see it's aligning the camera for the center of the field, and the camera is so big that we have stars out at the edge of the field. Boy, look at that. See how those are. Thanks, Doug. It was fun. Glad to hear your passion come through. You're nice, Tim. Thank you. It is 9:30, I realize. Uh, Boy, I'm sorry we didn't get more objects in, guys. I guess part of it is my fascination and learning the tools, huh? That's part of it. Oh, there's that. There's that one object with those splits coming out. I tell you what, I am gonna say that's it. We're just gonna declare it. Okay, I'm gonna take one more photo of this and then stop the live stacking. And we still have 7 people on. I know it's been 2 hours, and I don't want to be abusive, so I guess I should stop this broadcast. But I do just want to thank you guys for being a part of this tonight. I am going to go back, and I'll put you guys back in the targeting software. And before we go, I will do the last thing so you can tell I did it. We're going to say, let's see, general. Well, we weren't 100% sure, but one of our objects did have a kind of spike tail looking artifact at 180 degrees each side. Could that have been it? And then under the attachments, we'll just add that attachment. So in case the guys on cloudy nights do say, yep, that was it, then at least we'll have a proof. And if they say, you're dreaming, Lucas, then no harm, no foul, nothing lost, nothing gained. I'm going to grab this one with the 44 frames. Okay. Hey, thanks a lot, gang, well, there's Cheryl, just jumped in. We believe, Cheryl, that was Comet 11P Temple Swift Linear. Glad the skies were clear. Answer to prayer. Fun evening. You bet, Penny. Time for you to hit the sack. Cheryl, nice of you to join us. We think that was Comet 11P Temple Swift Linear, we think. So we are going to stop live stacking, and you know what else? If I discover another object that's worth videoing, we will upload a smaller video of just that object. And that way you can come back to our YouTube channel, and you can always find our YouTube channel in one of two ways. You can go to emeraldhillskies.com and look at the link that we always give you there to go to the YouTube channel, or you can just go to YouTube, and in your search box in YouTube, just search for Emerald Hills Skies, and I think you can put that as spaces between the words or as one combined word, Emerald Hill Skies, and you'll see a live stream of all of tonight's broadcast. Once we got started, we were probably, to be fair, I'll probably trim off the first 35 minutes. We'll put that live stream there, and then we'll also make a little shorter video of any of the objects that we find that are worth seeing. Thank you all so much for looking up in the heavenlies. To us, this is just a big proof that God is there. These kinds of light photons traveling across this kind of space by themselves just do not make sense to me. I don't understand how something could have happened like that by accident. So personally, this to me is one of the biggest examples of the fact that this couldn't have happened. And I just kind of believe that if you even presume that there was some kind of Big Bang and that exploded all these out, and so these are still traveling because of that big explosion, you just keep going back to that first cause that none of the cosmologists can explain because nobody has any idea where that matter came from in cosmology. But the only explanation I can venture is there had to be a God that made that matter and that compacted it. If he used the Big Bang as part of his creative genius, he compacted it and then with his power exploded it out. However you want to look at the origin of the universe, there had to be a first cause, and I believe that's God. So you can always learn more about that by going to sites like teamexpansion.org. They are the ones who actually have Emerald Hills as a site for their home office, and I owe it to Team Expansion to mention them because they're kind enough to let us launch Emerald Hills Live from Emerald Hills. So have a great night. We will look forward to seeing you again. You'll always get a couple of nights, hopefully, notice. And if you want to register to get that, you can go to Emerald Hills Lives and put your email address in the little form there. And that form, you'll see it explained. That form will email you a couple of days in advance, like we did this time. And you'll always have a little bit of warning. And you could always come back to Emerald Hills skies.com webpage, and then we'll tell if maybe weather came in and messed up our viewing or whatever. Thanks so much for being a part of this. We'll look forward to seeing you again. Another thing you can do is go to the Emerald Hills Skies YouTube channel and click on subscribe. And then there's a little bell there. If you do both of those, then when we've posted something new, it will actually alert you. And you'll have a little notification. If you've enabled YouTube notifications, you'll have a little notification there so you'll know we've placed a new little short video, for example, there. Boy, thanks a lot, and we will look forward to seeing you again. We're going to stop the live stream, but as long as these clouds don't roll in, we'll keep looking for exciting stuff to send up on those short videos. God bless you guys. Thanks for being a part of this. It did make it more fun.